So here we will be looking at some statistics related to permafrost. What is the permafrost coverage? It is approximately 16% of the global terrestrial area. And what is the soil organic carbon contribution? Approximately 50% of soil organic carbon stock in the terrestrial ecosystems. What is the carbon storage mainly in the northern hemisphere? Around 1014 gigatons of carbon in the top 3 meters. And how do we compare that carbon stocks? It is twice that of the living vegetations, or 1.5 times higher than the atmospheric carbon pool. What are the impact on the changes? Basically, there is minor change can significantly affect atmospheric carbon dioxide, because if at all the permafrost starts thawing, it will start releasing more and more carbon dioxide and other carbon gases which are stored in the permafrost. So emission from the thawing it is a substantial soil carbon emissions due to warming induced thaw. And what is the prediction? It is around 1.0 to 1.7 pg carbon, that is gigaton carbons per year over the next 300 years. And what is the temperature increase prediction? Because of the permafrost thaw alone, the temperature is going to increase by 0.20 to 0.44 degree globally. So there is a particular study which looked into the permafrost thaw and the temperature changes. The study period was basically from 2007 to 2016. The details of the thing is actually given in the IPCC report. So the monitoring depth was around 10 to 20 meters. This is near or below the intra-annual fluctuation depths. And what is the highest temperature? There are long-term monitoring sites in the northern hemisphere, and the circumpolar permafrost region showed that 2 degree to 3 degree, these are higher than the 30 years ago at some locations. And temperature increase rate was basically colder continuous zone, the temperature increase was around 0.39 degree plus or minus 0.15 degree centigrade. But in the warmer discontinuous zone, it was 0.2 plus or minus 0.10 degree. But the global average was around 0.29 degree plus or minus 0.12 degree. So these are all the temperature increase due to permafrost thawing. Then what happens to the active layer thickness? There is thickness has actually increased with regional variations are known. That means in some areas the thickness had increased, but not in all the areas. And what are the problems with the measurement? Basically, the mechanical probing may underestimate degradation due to surface subsidence from melting ground ice. So this is one of the major limitation. And with respect to the ground ice, what is the impact of the thaw? It causes the land surface subsidence and collapse, affecting the ecosystem and infrastructures that are built on the permafrost. If excess ice in the permafrost is lost, then what will happen? Basically, in the sand it is around 40% volumes, and the fine grained soil or sediment it is 80 to 90% of the volume that is present. What are the high risk areas of the thaw? Yodoma deposits in Siberia, Alaska, Yukon and Canada. And ice features especially the massive wedges, frozen soil sediment with pore ice. These are all the areas which will be affected. And what are the other areas which will be suffering? Northwestern Canada, Canadian Archipelago, Yamal and Gaidan Peninsula, Eastern Siberia and Alaska. So these are all the places which will be affected because of the permafrost thaw. What is the volume of grind ice currently there? It is estimated between 5.63 to 36.55 into 10 to the power 3 cubic kilometers. This contributes to a potential sea level rise of 2 to 10 centimeters if this much ice starts melting. And here additional information related to climate sensitivity, total organic soil carbon, carbon in soils to 3 meter depth. So these are all the data which are given, and more information can be found in the textbook. So what are the drivers of these changes? One is the press disturbances are there, which is a gradual change with respect to temperature precipitation, which affects the ground thermal regime. The second one is the pulse disturbance, which is a abrupt physical change like fire, thermocrust. This causes rapid impact on permafrost. What is the impact of the pulse disturbances? They rapidly remove the insulating soil organic layer. This leads to permafrost degradation very quickly. And also wildfire as a disturbance. What happens is the most significant pulse disturbance affecting the high latitude area is from the wildfires. Because when the fire is there, obviously we know the temperature is going to increase. And that is the reason the permafrost thaw will also be increased. So these are like disturbances which affect the permafrost thawing. The increased area burnt, fire frequency and extreme fire years observed in the last century. So what are the fire activity statistics are basically given here. And Arctic tundra is approximately 270 square kilometers per year in the Alaska, which is accounting to 7% of state's annual area burnt. That means the wildfires are actually destroying the permafrost region. And of course, other things include if there is a permafrost thaw mechanism, this leads to interaction in the environmental changes and the geomorphological process leads to rapid thaw. So this is also the driver for the increasing the permafrost thaw. And what are the environmental triggers? Extreme precipitation events and interaction with wildfire can also increase abrupt thaw. And what is the vulnerability? That means it is highly vulnerable. It will be degraded very quickly. And here is the permafrost with respect to climate change schematic diagram. And here is the receding. See, climate change leads to increase in the temperature. The increase in the temperature leads to melting of ice caps. And similarly, the climate change also goes to or increases the thawing of permafrost. This leads to lake and wetland drainage, which releases more of carbon dioxide and methane. So this actually destructs the infrastructure also because of the thawing. And similarly, in certain areas, thawing of permafrost also releases mercury, the contaminant which you saw in our earlier modules. And also this leads to various coastal erosion, and this overall changes everything, affects the socio-economic and the health of human beings. So that is the reason the climate change leads to change, or it's a positive feedback. The climate change increases the temperature, which thaws permafrost, which releases gas, which increases the climate change.